All right, today we're going to pull back the curtain on one of the most important technologies, well, literally shaping our world right now, deep learning. In just the next few minutes, you're going to understand exactly what it is, how it works, and why it's the real engine behind all the AI you're hearing about and probably using every single day. Let's dive in.
So have you ever wondered what's the common thread here? What's the powerful idea that connects self-driving cars, those incredible generative art tools, and the chatbots that feel almost human? The answer, you guessed it, is deep learning. You can think of it as the ghost in the machine, the core intelligence that lets these tools learn in a way that's, well, it's remarkably similar to how we do.
Okay, let's take a self-driving car. It's not just blindly following a map, right? It's actually seeing and understanding the world around it in real time. That uncanny ability to process a whole flood of visual data, other cars, pedestrians, traffic lights, and make split-second decisions? Yep, that's deep learning in action.
And you've definitely seen those jaw-dropping images created from just a few words of text. That's not magic, not really. That's a deep learning model that has studied millions of images and learned the very essence of what makes a mountain, or what a cyberpunk city looks like. And now it can create its own from scratch.
And when you're chatting with an AI like ChatGPT or Gemini, and it just feels surprisingly human, you're actually talking to a deep learning model. It's been trained on a library of text so vast it's hard to even imagine. And it's using all that knowledge to simply predict the most natural, most human-like response to whatever you just said.
So, to really get what deep learning is, we kind of need to see where it fits on the bigger map of artificial intelligence. It's super easy to get lost in all the jargon, so let's just zoom out for a second and get our bearings.
Our map starts with this huge continent called artificial intelligence, or AI. This is the big, overarching dream, the idea of creating machines that can think, reason, and learn, just like us. It's the whole shebang.
Now, let's zoom in to a specific, really important country on that continent: machine learning. This is where things get really clever. See, instead of a programmer writing a million lines of code for every single possible scenario, we do something way smarter. We just show the machine a ton of examples and let it figure out the patterns and the rules for itself.
And right there, at the very heart of machine learning, we find our destination: deep learning. This is the most powerful, the most advanced form of machine learning we have today. It uses a structure that's actually inspired by the neural networks in our own brains, which allows it to tackle the messiest, most complex problems out there, things like understanding images, sound, and natural human language.
So, to put it really simply, all deep learning is a type of machine learning, and all machine learning is a type of AI. It's just like those Russian nesting dolls, Each one fits inside the other, and each layer gets more powerful and more specialized. So, what's the deal with the word deep in deep learning? It's not just some cool-sounding buzzword, I promise. It is the absolute key to understanding how this all works. It all comes down to the power of layers.
Let's make this super clear. Imagine showing an AI a picture of a car. It starts with just raw pixels, a meaningless jumble of dots. The very first layer of the network doesn't see a car. It just sees simple things, like little edges and lines. Then the next layer takes those edges and lines and starts to form basic shapes from them, like circles and squares. Then an even deeper layer starts to recognize more complex objects by combining those shapes, like a wheel or a window. Layer by layer, it builds a more and more sophisticated understanding until finally, the last layer puts it all together and says with confidence, yep, that's a car.
Now here's a cool way to think about it. Not all deep learning models are built the same. They kind of have different personalities, and each one is perfect for a specific kind of job. So let's meet the three main players: the classifier, the creator, and the communicator. First up, we have the classifier. Its whole job is to make a decision. A simple choice. Is this picture A or is it B? Is this email spam or not spam? Is that a cat or a dog? The technical term is a discriminative model because, well, it discriminates between different categories.
Then you have the creator. This is what we call a generative model. And honestly, this is where the real magic seems to happen. It doesn't just sort things that already exist, it actually makes brand new things. It learns the very DNA of a dataset, what makes a face, and then uses that knowledge to generate something completely original. This is the true artist of the AI world. And finally, we have the communicator. You probably know this one as a large language model, or LLM. Now, it's really a type of creator, but its chosen medium is language. Think of it as the ultimate autocomplete. It's basically read a huge chunk of the internet, and its entire job, its only job, is to predict the next most likely word in a sentence. It sounds simple, but that one little trick is what lets it write poetry, write code, and even have a pretty convincing conversation with you.
So let's just recap that real quick. The discriminative model is the classifier. Think facial recognition or spam filters. The generative model is the creator. Think Midjourney making images. And an LLM, which is just a special kind of generative model, is the communicator. Think ChatGPT. Each one has its own unique superpower.
Okay, so we've met the different personalities of AI, but how do they actually go from knowing nothing at all to being so incredibly smart? How do they learn from their mistakes? Well, to get that, let's use a really simple analogy: an archer learning how to hit a bullseye.
For both of them, the goal is exactly the same: hit the target. The archer wants to hit the center of that bullseye. The AI wants to make a perfectly accurate prediction. And they both get better in the exact same way, through trial and error and lots of tiny adjustments.
Now, in the AI world, this learning process has a really fancy name: backpropagation. But forget the jargon. It's really just 3 simple steps. First, the AI makes a guess. That's the archer taking their first shot. Second, it calculates how wrong it was. That's the archer looking to see how far they missed the bullseye. And third, it adjusts all its internal settings to do a little bit better next time. That's the archer adjusting their aim. And it just repeats this whole process over and over and over. Thousands, maybe millions of times, getting a tiny bit closer to the bullseye with every single shot.
Okay, so we've covered what deep learning is, how it's built in layers, and how it learns from its mistakes. But so what? What does it all really mean? Why is this such a big deal? Right here, right now. Let's connect the dots.
Look, if you remember anything, remember this. First, deep learning is the engine that is driving pretty much every modern AI breakthrough you see. Second, that layered structure, the deep part, is what allows it to learn in such a powerful, almost human-like way. Third, it scales like crazy. It has a nearly limitless appetite for data and computing power. The more you feed it, the smarter it gets. And finally, its incredible versatility, its ability to be a classifier, a creator, and a communicator is what makes it so utterly transformative.
And all of this, it brings us to what might be the most important question of all. As these AI systems get smarter and more autonomous, where do we as humans draw the line? I'll just leave you with this to think about. Should a human always have the final say in a decision made by an AI? It's not a question for the future anymore. It's a question for right now. Thanks for tuning in.